Hey, so it's hilarious antique technology again. What I have here is an old Hewlett-Packard. This is a 700/92 serial terminal. Right now it's plugged into this Raspberry Pi, just over a serial port. Sorry, you can see that's actually how I do the videos. I have a screen on it. But yeah, so we have this is actually a fairly fancy pants terminal. You can see one of the things it does is it's got smooth scrolling. So, you know, apparently they've got enough buffer in there to be handling that. I actually got term cap working properly this time rather than on the previous one where I was not able to do it. I'm just treating it like a VT100. But, actually, I wonder if H-top will totally crap itself. Hey, look, it even handles it properly. That's actually pretty cool. So it's actually, you can tell you can turn off the menu. It's actually properly handling everything. It's only running at 9600 baud, mostly because I had trouble getting it running at 1192, which is mostly down to a whole bunch of settings wrong. I had like local echo and a whole bunch of other shit turned on the terminal and it wasn't responding, and I had to try and figure out what I did months ago to get all of this working in the first place. It's actually pretty fancy. It's got like the slow scroll, you know, when it inserts a line. So the keyboard on this is appropriately ancient and somewhat mystifying. It has lots of buttons which predate me. It's also missing a few, but it looks like Control, but if I hit Control C to dump out, it doesn't do anything. And I just kind of automatically I hit Print, which apparently just kind of, I actually don't know what it's doing. It's got Extend Char buttons, which I just don't have any idea what they do at all. Scroll down, scroll up. I don't even know what that does. It's got 4 blank keys, which is kind of amusing. Wrap, insert char, delete char, brief next. Yeah, so again, I have no idea what I'm doing. Technology is older than I am. Actually, this terminal is probably about the same age as I. And I can't hit F10 to quit because I only have 8 F keys that don't actually appear to be passed to the device at all. I mean, obviously there's a lot of shit going on in the terminal internally. It's got, you know, the typical fairly complex menu structure. So I'll probably actually hold on to this one just because this is actually, it seems to be properly VT100 compatible, which means I can actually use it. Yeah, there we go. So you can see it's actually in EM220 mode, but if I go into the menus, actually that's not the menu I want, device. So I think these log top, log bottom, and record mode are related to having a serial printer that plugs into the secondary serial port on the output. I'm not sure how they work though. Origins, tabs. It was letting me get into config keys earlier, so it may be that it's because it's currently busy. So the real issue right now is how do I fucking kill PS? It's cool, you can see the column where it's currently inserting, so I can turn off the menu option. Oh great, the power switch just broke. Well, I guess the power switch literally just stopped latching. Oh, that's apropos timing. So yeah, let's take a look at the inside. Let me get this tablet out of the way, and then just yeah. So it's got the the standard huge clunker of a keyboard. This thing weighs like multiple pounds. 5 volts, 50 milliamps. Most of these, I think, are they actually use serial comms. It's got the fun little flip-up giant bracket for displaying. It's missing some keys, and the apparently this is a tab key that it was acting like an enter key, but it's a tab key, I guess. The enter key's up here. I'm sure somebody will have more information about this stuff in the comments, but yeah, anyway, so just on the back, USB serial converter I'm using for talking to it. So Raspberry Pi, USB serial converter, and then this is a homebrew null modem cable. That's basically just swapping the TX and RX lines over. And then there's, of course, because annoying, it has to use DB25 for serial. So there's actually a so we have a DB25 to DB9, and then there's a DB9 gender changer, and then we have the null modem cable, which then goes into the USB serial interface. Kind of typical of stuff from that area, where you have just a great big stack of DB somethings plugged in, and each one plugged into another one, into another one, into another one, into another one, etc. That goes in that drawer. Then just Raspberry Pi, another Raspberry Pi. I have lots of them. I probably should have turned that off properly, but fuck it. Let's change views. I was going to change views, but then I realized I have no idea how this is held together, and it's a little big. So I'm going to try and do the disassembly. Oh yeah, something I didn't mention which is relevant is, so there's this flip down window here, which has what looks to be a, that's actually, there's an edge slot in there. So we have this window in which there's some, sorry. So that's an edge card slot for something, I guess. And then there's just a hole over here which doesn't appear to go anywhere. But I wonder what plugs in there. Maybe like terminal extensions or a modem or something. Because it's possible this thing is used remotely. It just basically, I think, if you have a modem hung, it might have a little bit of additional hardware, and then you could just hang, you could remote into your work system somehow. Oh yeah, also, so this we have here, these are brightness and contrast. Oh hey, there's the rest of the buttons. Alright, so that came off easily enough. A little bit of plastic here, which looks to be the power button. So, yeah, so this is that's power right there. And you can see, got these four are really big. Oh, I see. So there's these interesting rubber things here, which look to fit into these kind of similarly shaped splines. I guess that's for alignment, because these are kind of conical. It's weird. So then you can see here, these are these big snaps. You can see there's a little hook. So they pop over something and you kind of push them out this way and they come free. So it almost looks like I think it is. So I think that's on an edge card of some sort. It looks like this, sorry, is like a connection for an electrode connection for the screen. Oh, hey, I see how this works. So the whole screen just lifts out. Yeah, the screen is just sitting in there held in by the front panel. I don't think there are any screws in this entire assembly. Yeah, so you just have a plastic case with what looks to be a little metal shield in the I/O. And then here's the tube, or the actual display apparatus. Pop the electrode off the back of this screen. So there's the ground. And then there are the deflection coils. I want to discharge this. So I'm just using the fact this is a 200K input impedance multimeter to just as with a 6. It's probably not good for the multimeter if it was charged, but it's a cheap way to actually. So that white lead actually just may not be earth. So. So that doesn't surprise me. I mean, this was Hewlett-Packard in its heyday. I would expect them to design this to discharge itself without dicking around too much. But just good to check. Anyways, so. So, we just have a standard, good old-fashioned monochromatic CRT. You can see you've got your deflection coils back here, need little ferrites for tuning. There's your inner electrode. It's got the conductive paint on it. Very old school. This thing would probably look awesome running if I did it without, outside the case. Oh, fuck. So, I just learned that the rubber bumpers come off. Fortunately, without damaging the tube. I think. Yep, no bad thing. That'll just sit on the floor. And then there's our motherboard. So. This is considerably more Spartan than the other terminal I tore down. It's also considerably more dusty. But it's in pretty good shape, actually. So here's this interesting, I guess EMI control related thing. So we just have a bunch of tines that just push up against that copper strap, the implosion strap around the tube. That's kind of intriguing. This is also of note that it's got its own, they rolled their own switch mode converter. Oh no, this switch is fucked up, that's the problem. Yeah, it ain't latching. So we'll, anyways. So device-wise, doesn't look too exciting. So we have a SCN 2681 AC1 and 40, an AMD 1820 5335. That's a Hewlett-Packard type part number. So 1978, so it looks like this was like late 70s, early 80s. That's quite interesting. Look, we have a ferrite bead that appears to be soldered down on one end, and the other end is going through an unsoldered or a unplated hole in the board to just, I think this pad is the other side. Yeah, that's interesting. It's not a through-hole plated. Actually, the reason that doesn't look to be through-hole plated is because this board is double-sided but is not through-hole plated. That's quite intriguing. It looks like there are a few places where they use like a metal insert to make, you know, connectivity between the two sides, but it appears this board is 2 layers with only a single signal layer. The bottom side is their signal layer, basically, and the top side looks to be like a big ground plane. This thing is really cost optimized, I guess. So here's the back where we have the 2 serial ports. They're all Hewlett-Packard branded ICs. RGA, RQAD, RQAD 9042, Hewlett-Packard part numbers, RQAD 9042. 3222, 3222. I bet these are like serial transceivers of some sort. So here's your main serial interface, and this is the one for the secondary. We have a TQ4 something, I don't know. It's all Hewlett-Packard proprietary as usual. Caution, test before touching. Heatsink presents risk of electric shock. So there's our, I would guess, the main clock crystal, which is probably chosen for baud rate divisors. That is 29.4912 megahertz. We've got a big Hewlett-Packard branded ASIC of some sort. 1MJ20201 90501 B1 or IP32. And up at the front we have a NEC Japan D4464C-15L 9025 AD013. This is another Toshiba TC531001CP. It looks like this has a Hewlett-Packard part number, that one doesn't. Here's this edge slot of mysterious implementation. And you just have the beeper. That is a ST TDA8173 with some interesting diodes. So this is the contrast and the intensity control. So this is probably, you know, analog shenanigans going on down here. And then you can see here's their DC to DC, which uses a UC3842AN. I think that's just a cheesy, well, not cheesy, but just a generic switch mode controller. Interestingly enough, I don't see any opto isolators. You can see we have 2 power resistors here with holes cut into them, so they're probably intended for circulation. And there's definitely an isolation gap along here. Yeah, wow, look at that. Look at the beautiful creepage distance maintenance they're doing down here. I mean, this is well laid out. You can see that that device right there, which is the 2 rectifiers on that end of that transformer, have gotten pretty toasty, as well as some parts over here because of the discoloration. So this is the power device for presumably the high voltage. So you've got a big inductor. That is a pretty chunky inductor, sorry. Okay, so there's a big chunky inductor. There it goes. So you got a big chunky inductor, this big TO220 device. That's like a 1.5 microfarad film capacitor. That's pretty big and chunky, and it's mounted up on end too, which is kind of interesting. Got a tunable inductor. I think these are like MOVs. They all have this interesting slot cut in them, which I never remember why. I looked it up once and now I proceeded to forget. I've looked it up several times and I proceeded to forget every time what they are. You You know, and then here are your deflection coil drivers. You know, so somewhere in here, somewhere in here has got to be the driver amplifiers for the deflection coils. Oh, wait, of course not. I'm being stupid. So the deflection coils are driven from down here, so that might be some of these devices here. I'm actually not sure. I would expect that to be a pretty chunky transistor for that as well, and I don't know where it is. Or an IC, like a heatsunk IC, but all I see is this one TO220 device. Here's a little rubber booty with the little metal things in the interior. High voltage flyback. And that's about it. I mean, you can see here we have input filtering, cap, another cap, common mode choke, another cap, power switch, broken power switch. You can see we've got a little PC mount fuse. That's quite nice of them. I wish it was changeable. What is that? That is T1A 250 volts. So that's a 1 amp fuse. And you can see a lot of this. I guess that's probably also ground. Wait, that's a power resistor. I thought it looked like a cap from the top, but yeah, it's a big chunky power resistor. It's another thing that looks like it's got quite warm. Look at the board discoloration. Number of little TO292 devices. Lots of dust. Lots and lots of links. I guess it might have an RTC in here somewhere. It's interesting. Got a better back. That might just be for settings. And then it actually looks like there are a couple devices. So it looks like there are actually several devices under this grounding little harp thing. And they are I cannot make them out. They're made by NEC. D41464C. And they're both the same. So what I'm going to do now is I'm just going to pop this switch out. Quite interestingly enough, what it looks like. So this looks to be your... Sorry. Adjust the camera. So this appears to be the bridge rectifier for the input. So you have your mains comes in here, goes through here, is switched to these two leads. So then this is one diode and this is the other. And you can see here that, so obviously the two ground diodes are here and here, and it looks like they're actually using the metal support strap on this switch as a jumper, which is kind of wild. I mean, it's a clever hack, actually. I mean, so yeah, it's zero impedance. Zeros. But I mean, you can see how one terminal of the diode goes to there, and then the only thing that these two terminals are just the metallic support for the switch. I'll show you in a second. Dave Jones and I can have a desoldering gun off. Switches. These leads are too big. Or, correction, the soldering gun just not as temperature. So this is my kind of horribly shitty, well, it's actually not shitty, it's just kind of broken. It's actually an OK Industries branded SA1600 desoldering gun. It's just very tired. It's obviously I've fixed it like 5 or 6 times. You can see it's the very non-standard screws. I don't have any replacement anything for it. I really could use more tips at this point, but I don't even know where to buy them. I haven't really looked, to be honest, though. Alright, it's now in manual focus, so it shouldn't go out of focus as easily. You can just see. Got a big copper plate. Strangely enough, you can actually, adding some solder tends to help actually melt solder, just because what it does is it allows a better thermal interface between the soldering iron tip, or the desoldering gun tip, and the actual solder you're trying to melt. Sucked that for a pretty long time, but it doesn't really matter. This is not really a good demonstration for this because I don't have the right tip. Anyways, so maybe it is a good demonstration. So here you can see this metal bracket which they were using as the jumper from these 2 points, because now that it's gone, yep, nothing. So you can see it was those 2 points. And then just by having that bracket across there, it's kind of cute. So also, so this is just a double pull, single throw. Or single pull, double throw. I always forget which way they go around. But yeah, you can see obviously it's supposed to be push on, push off, but it was cranky for a while and now it's not working at all. Clickety, clickety, clickety. So anyways, what I'll do is I'll probably hack another switch into it, but there's the inside of a kind of a hilarious old Hewlett-Packard serial terminal for presumably used with HP UX, I'd imagine. So hey, I can probably hang it off that hilarious logic analyzer I tore down and make them work together, you know, be using it in the spirit of the era. So I guess the logic analyzer is about 20 years later. Hope you enjoyed.